Okay, so welcome back, everyone. So today, what we're going to focus on is kind of we're going to continue this series first of all, and then second, we're going to what we're going to work on today is verifying some of this legacy code still actually works, and kind of refactoring it to be also cleaner and and making sure it runs better. And remember, in the end, some of this code, once it's all done, we're going to create an airflow DAG to make sure it runs on a daily basis. That end product will be a little different than this, but in the meantime, we're going to just check to make sure it kind of still runs, and and then go from there. If we have some time, we might go back more into adding these additional data sources, but this is fairly common type of task when working at a company on creating a data set, particularly if the data set like this one was created a while ago, and there isn't any process to continually ingest the data, and some of the code might be broken and needing to be refactored. You'd be surprised, more times than not, a lot of the code is broken. So we're just going to jump into that in this step. So basically, we had different functions here to scrape the data from the USGS and to get like the closest weather station. This notebook is very rough. I honestly don't really like it because it's confusing and not easy to use. So we're just gonna try to pull some out of this to like a cleaner notebook, and then eventually to some actual Python scripts that we can just run. So let's see. So first, and we're just going to try it for 1 gauge right now. We'll just try this. So I'm going to see right now, I'm going to take some of this code, and the top part of this notebook was actually mainly looking at how to was looking at finding the closest gauge, and then the closest the closest weather station to a specific gauge. So some of that logic, I think, is actually going to be replaced. So like kind of as we outlined here, we're going to test this USGS function. So let's start by kind of doing that. Make USGS data. Just seeing if this still works, which hopefully it does. So we have this basic function, and actually we'll use some of the ones in the updated Kaggle dataset, because I want to update that dataset pretty soon anyways with some more recent data before we even release the whole 2.0. So for that, we basically have this was a subsample of the greater data set, and some gauges we just focused on that we thought would be more interesting than all the other ones. So I'm just going to use one of these. So basically the way this function worked was it would take a site ID, which is this, and then basically just a date time of when you wanted to scrape from when to when. So in this case, the site ID is this, and this corresponds to an actual U.S. geological gauge. So this is the St. John River gauge in Dickey, Maine. So this function should essentially return the flows of that from this time frame, whatever it was. So we're going to go ahead and just see if this function works. And if so, we might actually create like a unit test based off of that. So let me see. Bring changes to factor pipeline. Oh yeah, we have to do these various imports. So, and this function, it looks like depends on two other functions. Or these functions all kind of go together as a block. So we'll add these and then maybe create like a version of that. So we'll just see here. Oh, from typing import tuple. I guess a couple of these. Looks like we'll also need to import requests. And that should be enough to hopefully run this. So we'll just do make USGS data, and so we'll do it for this site ID, and we'll do it wait, I guess it's the start, so date time. Let's grab it for 0101. Just grab it from then till now, basically. And then see if that works. 07/24. And that would be the site ID. That should. Oh. Yeah, so you don't need to pass that actually. Oh, so this, yeah, we'll probably have to pass as a string. I think the function handles that. So let's see if that works. So it looks like that did create a data frame. So did create a data frame. We're just gonna assign this. Should have assigned that before. But yeah, so yeah, I'm gonna actually probably add this here. New window finder, flow docker. So, oh yeah, did I have that here? Scrape. Okay, that, I don't even know what that file was saying. So, instead, I'm going to cd dot. I'm going to create a file called USGS scraping functions. Oh yeah, touch. So yeah, I'm basically here just going to create a file called scraping functions, which is where we'll put these USGS related scraping functions. This will be kind of their new home in the code base instead of operating out of that. This is going to complain a lot just about flake. I'm actually not going to worry about that right now. So I will look at this df, see what we're returning. Does look like we're getting, at least in the head, a lot of nan values, which I'm not sure why that is in terms of cubic footage, at least. Oh, that might be because it's the winter. So yeah, so that actually makes sense, because during the winter there's not going to be a cubic footage. So that's actually pretty normal. I think we had functions there to fill that with something. But there, as you can see, there is a height, so I wouldn't be too worried about that. So it looks like this function still does work. And yeah, it does go for the right times. So yeah, that looks correct in general. As you can see here, in the summer there is cubic footage. So I'm gonna go ahead and yeah, probably then try to make just a small unit test for that. Or no, I'll just call this test. It's probably better. And then we'll just touch usgs test.py. We're just going to create a small test in here for this. I think, what was it? This was supposedly, I think, I think the Copilot was supposed to be able to architect these. I don't know if it will. Yeah, why don't you do that? We'll create them. It would be nice if it actually did. Let's see if I can get it to actually create it. Or if it won't, like... Oh, do I go to that one, though? I haven't actually used this to create unit tests before. Well, there it looked like. Okay, whatever. I'm just going to... Okay, that's fine. That actually is right. But no, I just want to import from... Okay. We'll figure out the file paths and everything later. Class. Oh, see, maybe it will create it. I don't know. Or it's set up, right? def test. Oh, maybe it will create it. That would be nice. Is that what I really want, though? Oh, yeah, actually that... No, but that will return a data frame, so I don't think data frames you'd actually call shape. So we'll have to change that. Len, so it'd actually be len result should be 24, right? I have no idea if this is actually an ID. Maybe it is, maybe it isn't. Or did I paste that? Maybe this is actually a gauge ID. Oh, it actually is. It just came up with the Potomac River, actually. That was interesting. Anyways, so okay, that actually doesn't look bad. But yeah, so for now I'll just set that up. We'll add some other tests later, but more what I want to do right now is actually see if I can end-to-end create the flow output for that time period. So okay, so I'm gonna go back to that. I will commit this just to say updates for refactor. Scripts, added basic scripts and a unit test template. Still need to set up CI and all that shit. Okay, so we will commit that just so it's there. Obviously there is no CI file in here right now, so it's not just going to work. This was originally designed just to store the notebooks, but as we refactor, we'll put code there as well. So let's go back here. And we'll go back to this. So this return obviously the data frame of that time. We said it looked good. So we know those functions are working. So after create USGS, process intermediate. Oh yeah, we had this function called process intermediate that I think, and unlike this other notebook, I am going to keep this notebook fairly clean. Oh, wait one sec. So, as I was saying, what we're going to do is, yeah, still keep this notebook pretty clean so someone would easily be able to run it step by step, unlike the other notebook, which kind of sucked that way. So, FlowDB dataset building 2.0. So we'll just add that. One. So okay, so we did that. So basically, yeah, step one is just get the data for a specified period and site number. This will be further generalized, obviously, but this is just showing an example end to end. So yeah, let's now go back to this. So we had the process intermediate. So this looks like it just does some processing on the data frame. Okay, we'll just say that for now. So let's make sure this function still works. What's it saying about this? Oh, apparently this isn't allowed nowadays. I don't know. Okay. So it looks like from the original code, basically this function, I will add kind of a better doc string to it. Looks like it converts all time zones to UTC time. Converts local time to UTC time. What else does this do? It looks like it makes this CFS column into a numerical column. And it also gets the max and min flows and the total number of NaN values. So though actually I think this is one function we could definitely improve on a lot, because as I was saying, there are some NaN values I think in here because legitimately all the data is actually missing, and then there's some NaN values in cubic footage just because it's the winter and the river's not flowing. So it would be better to actually have this function count, and obviously like if it's just winter, then that's, I mean, they're NaN values, but they're NaN for a different reason than the data is like missing. So so that's something else to think about. So I don't actually know about that. So one of the things, yeah, because yeah, it's a lot more problematic if, say, like both of these columns are NaN, because that means it's really not recording. But the other thing is actually not all gauges though have height, so we can't just broadly apply and say, you know, always use the height to count the number of NaN values, actually a large number don't. But for just this one, I'm just gonna quickly check and get the numbers. Is NA, I forget, like, what's the quickest way to count number of NaN values in column pandas? Oh, dot sum is NA dot sum. So here 275. If we look at cubic footage, it's going to be 22,620 and 682. So obviously the number of legitimate NA values is very different. So that's something that really should be dealt with. And they should probably be encoded and replaced a bit differently. The winter NA values versus the summer. I forget if I had a function to do that, but actually I don't think I did. So that's stupid flies. Count NaN. So that's kind of a problem there. But in any case, so I don't know actually if that's great too. This function does. What we could do, since some of them definitely do have height, is if it does have height, we could use that. Otherwise, yeah, because I think that might be more accurate. So let's look at that. So NaN. So count NaN. Or we actually, does this function do anything with the count of NaN? I don't even know if it does. Looks like it just creates it and then doesn't even return it. So I don't know why the original function did that, but yeah, I don't know. It doesn't even see if it returns it. It doesn't even seem to return it at all. Just calculates it. But then it doesn't return it. The rest of this looks pretty good. So I would generally maybe we can come back to what it's actually doing with the NaN values. Processing intermediates. Okay, and this was the time zone map, I think, that this function talks about. So we can just paste that there. That's pretty self-explanatory, I think. So basically then so actually this function I think is called by another one of these functions. So this create USGS function, which is right here. So I guess that's what we talk about here too. Keep doing that. I should just put this on the end. Okay, so we know basically, well, in any case, let's just test that. too to make sure it works. So we'll test that and separate that with some text. So process intermediate CSV. I'll just put the DF in. In theory, this should just run now, would be my guess. Time zone map. Do I have to throw this up here, maybe? Now it's giving me an indentation error. Okay. So let's see if it does that. So it looks like basically it did what it said. Got the min, the max, flows. So basically, what this function is it's definitely a lot more complex, but basically, this function used to essentially loop through the different gauges, create that USGS data, and then call that like process intermediate that we just looked at, and then basically use this metadata that I think was gone in some other way. Well, gone from the river, another river ID thing, and I had then stored in a JSON format. So that's kind of what this thing did, and then it did all this kind of like manipulation. But instead of doing this right now, well, actually, maybe we can look at how the metadata was created too. That might be worthwhile. Though the metadata doesn't really change. Like that's going to stay the same. So it's not really as important that code's robust and still working, because we have those files saved. But like we can still look at it. So I think the metadata was created by getting a list. Oh, even this notebook doesn't do it, really. Okay, so that's not something this notebook even did, was get that metadata. So, well, as I said, that's not really going to change, so we'll assume we still have this stuff, which I think we do. I wonder if this gauge is actually in the metadata. Let's see. Or actually, I think I uploaded it here. But I will just grab it so people can see what it looks like. So I think, yeah, this was the one I was using. Or what was the ID? The site ID I was using was here. So we'll go here. So this is what the metadata would be. I'm gonna just download that quickly. No, I do not want to download it there. Riverflow notebooks. Actually, I'll probably use this in the test, so I'm just gonna save it here. So that will be the JSON file saved. For now, I'm actually gonna upload it to this notebook too. Or actually, it would be better probably to just do a wget. So I assume I can do that from Kaggle, actually. Wget O. And we'll just call it, site. JSON. So we'll just do that. I assume I can just do that from Kaggle since it's already uploaded there. But we'll have to see. So datasets, FlowDB sample. So let's look here. I just had that URL. I don't know what happened to it. Was this one right? Or which one? I have that. Okay, there. So, you copy the link. Oh, fuck. I don't know how I get the link to it, actually. If I go here. History. Yeah, if I can just get that URL or something. So, I think I can do that, right? It's a long ass URL. Wait, that's a zip. Let's see if that works. Bad request. Okay, that's fucking annoying. I'll actually just upload that to my own cloud and just make it like public access, because it's already public access on Kaggle. I don't know why it wouldn't be. I think I have a bucket that's, I should upload it here somewhere. Yeah, I'll just upload it here. That way I think this should be public access. Just make it, because I don't want to have to do authentication every time I log in. And it's already public anyway, so I want people to just be able to use the notebook access. Okay, I'm not going let me see. Flow datasets, edit access, there we go. Bucket permission. Okay. Let me see. Simplified. Alright, I'd use GSUtil here. CP. I think that would work. Oh yeah, it's not. Let me see. Makes whole file make data public. I don't want to make all objects. Add permissions for all users. Select all users from the name. Select reader for access. Okay. Select. Edit access. Oh yeah, and add entry. Public reader. Okay, reader. Yeah, that's what I want to do. So that should work now. That was a lengthy way of doing it. But in any case. Okay, so this is already starting to get messier, which I don't like. So what am I going to do? I'm going to actually, I think I'm going to remove this for now, because I'm more concerned with the individual file. So we will now download the metadata for this station in order to continue getting the precipitation data from ASOS. So here we go. We just import JSON. Sync the classic thing with open. What's this called? I think this would be the file path as F or as, let's do as M. JSON.load. Is it JSON? I always get it mixed up even after years of programming this way. It's JSON.load or JSON.loads, but I'll just say metadata. Could be JSON.load, or maybe it's that. I guess it was that actually. So here you can see we have this kind of metadata now, which has the ID, latitude, longitude, the name, the time zone offset, etc. Soil data. Oh, it actually does have soil data in this. I forgot that they actually had soil data. Elevation, resolution, what else? But most importantly, it should have the ASOS gauges. So basically here, and this corresponded to this crap with the Haber sign and all that, like where we got the distance, this function basically produced this metadata that showed the distance from the station to the from the river gauge to the weather station. So so this basically showed it had this station FVV, and it looks like, do you have the distance? Oh yeah, there's the distance in miles. So you can see actually in that data set the closest weather station, at least the closest one we had access to, was actually like about 61 miles away, which isn't good, obviously, for forecasting, because obviously, well, it depends what the topography of the region is and what the drainage basin, but ideally you'd have a weather station much closer to get the precipitation data. Then there was another one 65 miles away, and another one 85 miles away, and another 92. And these were the 5 closest after we made that calculation. So yeah, that's one of the things we're going to be doing with the precipitation maps, is hopefully those are a bit higher resolution. You can show better what the actual precipitation was that actually hit that area instead of this. But until we do that, right now we're not going to worry about that as much, and we're going to just try to get the CSV file out of this that we had, similar to the FlowDB one. Make sure we can still at least get that CSV file. So actually though, what I will do now is for the purpose of kind of this exploratory notebook style, is I will do metadata. What is it? Or I'll do that on the next line, actually. I will let people see that. We'll do metadata. I'll clear the output though, because that's kind of a long output. So we'll just do metadata. And then we'll do, I think it's stations, right? Yeah, so, and then this is basically that list. And then what the, so weather data, so this get weather data function, what this did is it basically got the weather data for one of these stations. And we're going to see if that works still. So now let's get the weather data. Speaking of weather, it started to thunder right here. For this station. Actually, we'll do it for 2 stations. One of the things this did too, the original code only looked at the closest station. I think actually by having multiple stations, depending on where they are, could actually be useful too, so that the CSV actually has more data in it, so it can better learn some of those dependencies. But in any case, we'll paste that there. Okay, so we'll see if we can import from typing. Import set. So there we go. So now let's try this. File path. Oh, so yeah, originally, because like some river gauges might have used the same station, in order to like not, so to speak, have the code visit the same station twice, scrape the weather data, the same weather data again and again. It basically just scraped it once. So that's where that file path is from. And so there was this, like, we made essentially this cache, like a naive cache of different stations we'd already gotten the data from, etc., etc. So, but anyways, in order to avoid visiting it most times, but so right now, oh yeah, then again for basically it went through the different, the other thing is this would open one of these files, and as you can see it would loop through it. Gauge meta info. Did this actually create the file though? I don't know if this actually dumped the file. So if it has that, let me go back to this process. Oh no, so it was this function that actually I think got the data from ASOS. So I think that function might actually have called that function. Or maybe not. Let me see. Okay, so we'll just try this actually. I tried this instead. Get weather data. Gauge meta info. So I don't know if that actually got it or not. Okay, with open temp weather data. Base URL dot format. Okay, I think this is what got the actually got the data. Process ASOS. So this actually, I would simplify to another one, its own code, because I think that would be useful. Where just making a function where it gets the like weather data for a station, because this function is kind of already long and kind of spaghetti like. But if you take this then that would probably be useful. So actually, let's just look at this code. Let's simplify some of this code. I think we're going to turn this into its own function. Just this elf if block. So let's do that. Obviously that's gonna station ID. What am I doing there? Station ID. And I'd have base URL almost be default. And actually this would just be like some dict or something. So this will get us the actual. So we can remove this block. Remove the else. And oh, do I need that? Probably. Stations explored. I'm just gonna say let's say that So all this is important for doing it when like scraping on a large scale, but that code could stand to be refactored. Also, we're going to need to make it like smaller scale for running a daily scraping thing for the DAG anyways. So that's kind of what I'm doing now. I'm not going to worry about this. We can worry about how we'll upload the file later. When running the scrape, it made sense because we were processing kind of thousands of files. So it was important to upload files as they came in so important results didn't get lost. But right now I'm just trying to kind of break it down for one thing. And there's a lot of code we'll be adding when we add these other data sources. So it's important just to simplify this now and then probably build some of that other stuff back in the future. Okay, so let's see. Then we just need that process ASOS function. So let's see about that. What was that format DT? That looks like another function. Okay. So a lot of this code too manage this problem with time zones as well, because they're obviously different time zones. Time delta. Should I do time delta? Okay, so I was actually gonna, not do that, have that right there right now. So, get lever data. So okay, we're gonna just do this. We're gonna just try to do this here, see if that works. Station ID, so in this case it would be FVE. And the base URL, I think we had the base URL before. I think we deleted it actually. It's a long and fucking ass thing. What is the difference? I don't know. I don't know why there are two base URLs, but so we'll just grab this one, see if it works. So this was actually a Iowa site that they built. I think University of Iowa actually built out an API, which is pretty nice because otherwise retrieving ASOS data was even more of a pain than this. Yeah, so we can actually just do that and then have base URL. Don't we need a start time and an end time too? I think so. Yeah, so actually that URL already has those in it, but we're definitely gonna want to have that just be fillable. So we're gonna actually add these as parameters. Start. So yeah, these should be time and time. So how am I gonna have that subbed? So we're gonna have to somehow sub the shit in at the right places. I know the easiest way to do that. Let's see. start time, end time. Yeah. Dot format. So we're gonna have to do some like base URL stuff. I don't like how they do that, like with the URL though. And format. So I guess we could use dot format. Though. So if we have 2 date times, so okay, well we'll have to do that more extensively later. Maybe for now just do the year. Start time dot year, end time dot year. So if we had, oh wait, there's already a dot format though. Shit, I forgot that, because there's a dot format like when you get the oh yeah, we're already formatting it. So we're gonna have to add these in. Okay, so station would still be first. And then we're going to do start time dot year. Right now I'm only going to do a dot year because I don't know, the rest is a pain in the ass. Dot year. Just put that there. Dot year 2. Okay, let's see if that just works. Base URL. Then what's the date time? Oh yeah, we just do date time. Like I think we did, what was it, 2021. Date time 2023-01 or 07/24, something like that. Oh yeah, again, that's stupid shit. I don't know how that will work though. Okay, yeah. Key error, station ID. Oh wait, station ID should just be there, right? Yeah, it shouldn't. Yeah, that's right. So yeah, it should just be station ID. Year 1, month 1. Okay, so I actually did get some shit, it looks like. Obviously, yeah, that other stuff isn't present. But, okay, well, so this is some progress on this. I'm going to actually end this for now as I have to get going, but, that's kind of the overview of some of the refactoring we're doing. And besides that, yeah, just keep tuning in. I'm going to try to get these on a more regular schedule. But yeah, together we'll keep building out the 2.0 of the data set, and yeah, it should be good. So yeah, good time to head inside too, because it looks like it's about to sunder out here.